from this computer. Okay. So last time we were doing probabilities and we took a test over probabilities. So I'm getting close to grading and getting updated on that stuff. But should get that. I'm hoping by this week, if not next week. And so we got 2 more weeks left. We got 5A, we got 5B, we got 5C. And 5A, we're going to introduce statistics. 5B, we're going to basically, excuse me. So 5A, I guess we're going to go over that today. But 5B, we're going to introduce, what was it? Determining, or we're going to basically scrutinize statistical studies in 5B. So we're going to go over different like criteria that we want to look for with sources and stuff like that to determine whether or not something's credible. 5C, we're going to do a little bit more about probability tables and things of that nature, and doing probability distribution tables. And so I think someone asked, why does like 7 come before 5? And typically, when I took my probability and statistics classes, they teach you probability along with statistics. They kind of go hand in hand. And I want to say I learned probability before I learned statistics. We're going to talk about probabilities when we talk about statistics. So it kind of makes sense to put it first. Define the things before you talk about them. So this is not something that we're going to talk about, but this is something that a lot of people talk about. You might have a class that's graded like this. So if you might need to know this, maybe somewhere in your college career, but maybe they say that anything over here is an A, anything over there is a B. Let's redo this. What am I doing? So maybe they're saying like that's an A, B, a C, right? They might be doing something different. Some professors like to try to get their things. And so what this is called is a normal curve. And so if someone gives you a mean and a standard deviation, and something maybe to notice is that this thing isn't skewed, it's centered, it's symmetric. It doesn't look like that or like that. That would be called skewed. It's got a big leg running out. So I might talk about a lot of things that maybe aren't particularly on your test or something, but they're on the test of life. This is something that people talk about. Right? I can go out there and I can talk to people about this. They will know what I'm talking about. There are, like I said, sometimes professors like their class to be graded like this. So if your class is graded like this, what is your professor talking about? I don't know. Give me a mean of, 80, and maybe a standard deviation of 8. And so you'd have to figure out, well, my mean is at 80. Ooh. I think the SATs are scored like this. A lot of placement tests are. And we're going 8 each time. So we're going up to 88, and I think we're going to be going up to 96 for 2 standard deviations. Going up 8 would be going up to 104, I think. 104. Yeah, 104. So we go up 8 each time, and we would go down 8 each time. So what's it? 72, I think, would be this one. 72 minus 8. Oh, God. I got to carry the thing. Okay. For 64, is that what I'm right? And now minus 8 in my head again. Oh, man. That's what, 56 or something? And so if your professor was scoring something like your test, you'd have to make between what? I guess this would be your A probably. They'd probably make this an A. Anything between 96 and 104. Anything between an 88 and 96 would be B. Anything in here would be a C. Anything in here would be a D. Anything lower is probably an F. So they could do something weird like this. This is called the normal curve. You might hear like this person is above the curve. I think that's what they're talking about. Like you're scoring better than the average person when they say you're above the curve. One thing that you will get tested on if you go into statistics is this rule called the 68, 95, 99 rule. And so that is a rule that if you have a standard normal curve like this, between one deviation, you'll get 68% of the people scoring in here. If you do 2 standard deviations, that means 95% of the people in the class scored between 65 and 96. So we can get sections of the population like that. Are there any questions over anything that I talked about in the notes? Was there anything confusing? I think we introduced observational and experiments, observational studies and experiments in this section. Did I log in? I logged in. That's a picture that you probably will not get tested on, if I'm being honest. I don't think we cover the 68, 95, 99. But it is a thing out there. This is the thing that we will be talking about today. And so I hope you have this sort of like general picture in your head. I'm not sure if I would even include the start bubble. I'd probably just think about a population. So I have a population of people. Let me think about something. This could be like what? The US population. So if I'm talking about the entire US, I wanted to state a goal. And the goal is not something that is biased here. So it should probably be clear. The book should probably be a little more clear. If they're telling you to prove something with statistics, that's usually when you tell that person to get bent, because they're telling you something to do something like really immoral. Like you don't go trying to prove something. You let the numbers speak for themselves, and then you say what the numbers say. So beware. There's some people that try to do unethical stuff. But if you're talking about the entire U.S. population here, I want to go with the width of their big toe. Am I going to go measure the width of everyone in the U.S., of everyone's big toe in the U.S.? That sounds like something that is probably not very easy to do, probably something that's not very achievable. So what am I going to do instead? I'm going to do this thing called choosing a sample. So we want to choose a sample. Ideally, and this word here is kind of pertinent, right? We want it to be representative, meaning we want whatever trait, the big toes here, to represent the big toes here. We don't want them to be off. If it's off from this population, that's what we call bias. You'll probably have some bias, right? But the goal is to kind of minimize that bias. And so we want to choose our sample in a way that it's representative, that it's going to represent this. If not, we get this thing called bias. So what do? We go to these people. I don't know. We're not going to choose the entire U.S. population, but let's just do, 100 people. That's a lot of people, but it's better than, 7 billion or whatever? 7 million? 7 billion, I think, is what the U.S. population is, right? That's world population.
I think the U.S. population is 300. Like 700 million.
Yeah, it's hundreds of millions. U.S. population, what does it say? 300 million, that's what it is. We did this like not that long ago. I don't know why I can't think of it. Not something I memorized. 7 billion is the world population, right? Yeah, 7 billion is the world population. Okay, so I'm not going to go to 300 million people. I'm going to select 100 people. How I select them, we're not getting into that right now, but I'm going to select them somehow. I'm going to go measure the big toe on each of these 100 people. So hopefully I clean my hands in between each turn or something, make them shower their feet before hands or something. I don't know. Seems like it's getting a little nasty, but whatever. Sometimes we got to do a little nasty work in science. So 100 people. We're going to go measure the big toe. We're going to get the measurement of the big toe of the 100 people. we take this 100 people big toe measurement and we try to say something about the measurement of the 300 million people's big toe in the US. And then after we do that, we try to make some sort of conclusion about what this says about the US population and their big toes. How does it compare to other populations and their big toes? I'm so glad we can talk about super important stuff, but this might be important too. Like I know I'm using big toe, but foot length, right? It does correlate to your height. That's how they find, like if if there's a detective on a crime and they have a shoe print, that's how they figure out how tall the person is. So I know I used probably a little bit of a silly example, but this is kind of the idea today, or the idea of like a statistical study is we're not going to study the entire population. It's not realistic to do so usually. We're going to grab a sample and we're going to pull from that sample some kind of data. If we do things correctly, hopefully it's representative sample. We take our sample statistic, we try to make some kind of inference about the population, and then we can make maybe some kind of conclusion afterwards. But like I said, if someone's telling you to start with the conclusion, telling you what you should be inferring, that's when you tell them, I don't think I want this job. Population and sample for the following studies, identify the population, sample, population parameters, and sample statistics. Okay. So there are a lot of things they're asking you for on here. So let me get them down one by one. Where's my text? There it is. Okay. I want population sample, population. I want a sample. I want a population parameter, and I want a sample statistic. And so in this example, what are they telling me? They are telling me I want, in order to gauge public opinion on the president's plan to contain Iran's nuclear program, the Pew Research Center surveyed 1,001 Americans by telephone. And so what is the population? What is the big group of people they are trying to say something about? That is not the population. I will give you that much. The population is all Americans. This sample is the 1,001 Americans that they actually sampled. So the population is all Americans. The sample is the 1,001 Americans. And what's the population and the parameter, and what's the sample statistic? That's the next two that need answering. I'll just answer them. You can type it in. You can tell me either way. I'm just looking to get these answered, basically. Can we answer them? Do we know what I'm talking about?
I think we know it. We're just like trying to fit it all in the one thing.
Oh, we already got the first two. I just need the last two. Population parameter is the public. Woo. That's not the population parameter. That's the sample statistic, is the opinion of the 1,001. Okay.
I have no idea what the last two could be.
You told me the sample statistic. You told me population parameter, but that's your sample statistic.
Oh. So with the popular parameters, would it just be all Americans? Like the population?
All Americans, what?
All Americans' opinion?
Yeah, that's it. Opinion on President Iran deal, right? Whatever the heck they said.
Yeah.
The 1,001 Americans. on President Nuclear Iran deal. And so these two things, they should really be like the same. They're the same thing, but we're talking about this is the statistic on your population. This is this statistic on your sample. So the sample statistic is going to be the 1,001 Americans' opinion. The population parameter will be all Americans' opinions. And so again, we start with the population. We draw a sample from the population, 1,001 Americans. So now we're at the sample statistic. And I feel like that maybe they wrote these backwards. We should really talk about the sample statistic, 1,001 American opinions, because that's where you're drawing your conclusion about what all Americans think. Are there questions on this? Maybe put a little more spaces up in here. Okay. So I think we're going to get like one or two of each starting off here. So I think we'll get something pretty similar. Oh, excuse me. Next slide. Yeah, that's good. All right, I think it's the same question, so let me delete some of these annotations. Recycle, delete that. Delete this much and this much. This is the one with the ears of corn? No. The notes had the ears of corn, I think is what it was, huh? Okay, same thing here. We want to know population. We want to sample. So we're doing astronomers typically determine the distance to a galaxy by measuring the distances to just a few stars within it. And then they take the mean or average of these distance measurements. That's what it said. So what is my population? What is my sample? What is my parameter? And what is my sample statistic? So basically, there's a galaxy far away. I'm not going to go measure every single little star in that galaxy. I'm going to measure a few stars. So the population is the galaxy is what they're talking about. It's over a little bit. This is all the stars. The sample is going to be the few stars that they picked, right? Population, I want to start with maybe sample statistic. So I'm going to pick the sample statistic. Few stars, yes. Yes. And so what is my sample statistic? What does the thing actually go and measure and get? Yeah, so this is the thing I'm actually measuring, the distance to the stars picked. And the thing that's the population parameter is the distance to what? The galaxy. Or all the stars. Are there any questions about this? Are we getting this? Are there any questions? Is there any thing that's weird or throwing you off here? Okay, silence. I'm gonna assume that means you understand what's happening. If you don't speak now, then I guess you're forever holding your peace. Okay, so I think this one may be a little bit different. This is where they want us to use the basic steps in the statistical study. You want to determine what percentage of high school seniors regularly use a cell phone while driving. So this, I think, is more like you're going to conduct your own experiment. And so you're in high school and you want to see how many seniors regularly use a cell phone while driving. So the first thing is state the goal of your study. That is, determine the population you want to study and exactly what you'd like to learn about it. So what's your population here?
High school students?
Yeah, I would be a little bit more specific. I would say seniors, right?
So all seniors in high school? All high school seniors?
High school seniors, yep, that's it. But yeah, you're talking about all the high school seniors. Depending where you go, and you're going to be you're probably going to be relying upon like voluntary, people to voluntarily admit that they're doing it. So you're probably not going to get everyone's probably not going to want to answer you on that one, right? So you're probably not going to go interview every last high school senior that there is in your school. You'll probably select a sample somehow. So choose a representative sample from the population. So how would you choose a representative sample?
At random?
Yeah, you have to choose people at random is one way that you could do it. You could randomize it with a computer program. This is one of the ways, like, you're gonna have to be creative. I don't know what to say here, but like this is gonna take some creativity. Anything you do is probably gonna have a little bit of bias, if I'm being honest. If you go interview, do the simple thing and interview people in your immediate classroom, right? It all depends what class you're taking. If you're taking an honors class, you're gonna get bias there, right? If I don't know what you're taking, but there's always the potential for bias there. So you want to do something that's representative. If you telephone call everyone, then you're biasing the people that own telephones, which is almost everyone now. But collect raw data from the sample and summarize this data by finding sample statistics of interest. So if you're going to collect data and you're asking people to admit to something that's illegal, probably, you're probably going to want to make it in an anonymous survey, something along those lines, right? Something to where they're not going to be able to get identified. So there's a lot of sort of problems that maybe arise due to the nature of the study. These are all things we have to consider when we conduct studies. And so there's not really going to be like maybe a clear cut, like this is the correct answer like you expect in the math, right? There's going to be a few things that you can do. There's a few things that are probably better. There's a few things that are probably worse. There are a few things that you definitely shouldn't do. But these are not like sort of, what do I want to say, typical like one solution, clear cut math sort of things. You might have to like write a sentence or two. I don't know. So collect raw data from the sample and summarize this data. So you're going to go ask them probably in a survey, do you talk on your phone while driving? Or maybe you could even ask more questions than that. That kind of leads them into answering more honestly. But you're going to ask them somehow whether they use their phone while driving. You're going to conduct a survey, most likely. You're going to look at your sample, at your survey. How many people said yes? How many said no? That would be like step 4. And you're going to try to say something about the population. Do these people that I picked represent the entire population well enough? How well do they represent the population? I think we talk about margin of errors. So you might give me within some numbers, it might represent the population. And then we want to draw conclusions. Determine what you learned and how it addresses your goals. Is this a trend that's happening? Is it getting worse? Can you look at previous surveys from previous years, see if the trend is getting worse or better? Can you look at other schools and see how your school compares to other schools? This is the part where we want to start maybe comparing it to other studies, doing things outside of our study, right? Our study doesn't necessarily exist in isolation. It exists in isolation while we're conducting it. Then we can compare it. I grunt weirdly. It's just like, I don't know. I got this sore back muscle or something. I don't know what it is. But that's where these grunts are coming from today, if you hear them. So draw a conclusion. That's it. Are there questions about this? Is this something that you could dissect and tell me how each of the steps could be applied to this? So step 1, do this. Step 2 means you're doing this. Step 3, I think I pretty much said everything, right?
Yeah, I don't know. I have no questions, but I can't speak for everybody else.
Yeah, I understand it pretty well.
Not sure how number 4 would be applied. So this is you're using the sample statistics. So you're going to talk about your survey. So let's say you have a senior class of 300 people. And that's your population. But your sample's not going to be 300 people. Your sample might be like 20 people or something. Maybe you're lucky and you get 20 people to answer your survey. And so we're using our sample statistics. So out of the 20 people, how many people said they use their phone while driving? Maybe, I don't know, 12 out of 20, 0.6. So we're going to say 0.6 or 60% of the people use their phone while driving. So we're going to try to take the 60% of the people that we sampled, and we're going to try to say that maybe 60% of these people were also using it. That's where step 4 is coming in. We're taking our results from the quiz that they're taking or their survey. We're taking these results and trying to apply it to the whole big population. Yeah. This is a really, and I'm glad you like said something, because this is a really weird step. Can we do this? Are we able to do this? Maybe it's not 60%. Maybe our survey only tells us it's somewhere around, like, maybe it's like 55 to 65%. Usually we get like margins of certainty when we do studies. We don't usually get like a flat number, if I'm being honest. It tends to be like these margins, like we're 98% sure it'll be between these two numbers or something. Kind of goes back to that first picture I had with the normal curve. We get intervals that we get. It's almost never going to be exactly the same. So usually they have to give intervals here. They don't go that deep in this book. But it's a thing out there. Are we? Next slide. Slide to the left. Cha-cha now, y'all. It's such a weird song. I don't know, like, just came out of nowhere. Okay, so we're going to get 4 different samples. We want to determine whether these are representative samples. So this is a thing that you're going to have to do. You have to look for biases in however you're choosing your sample. You try to account for it. You try to be aware of it. Try to minimize it as best as you can. What does it say? You want to determine the average number of classes skipped by first-year students at a small college during a particular semester. State whether each of the following samples is likely to be representative and explain why or why not. So I'm looking for any potential biases here. So the first sample is 100 first-year students, and they belong to a sorority or fraternity. So is this likely to be biased? What is your bias here?
Belonging to a sorority or fraternity.
And how might that affect your results?
You would be more focused on the
People in the group rather than the whole.
Yeah, well, you would have that social net of people probably pushing you to go to class, right? And so these people, they might actually go to class more than other people because they have that sort of social support net, maybe. I think that might be what they're hinting at. Who knows? It might make them less likely if they party too much. I don't know. I can't really speak on behalf of what it's like to be in a sorority or fraternity personally. So this is the key words, right? These things are likely to bias your sample. They are members of sorority, fraternity. It could be biased there. 100 first-year students who played a varsity sport. So what's your bias here? I'll give you a hint.
The varsity sport.
Yeah. The thing that they're saying there is playing a varsity sport. Why would that bias your sample?
because it's only focused on the sports people.
So how would that affect whether or not they skip classes, I think is the question here.
Because they'll probably be more
Practice.
focused with the sport that they're playing, and they'll train more rather than go to like their academic classes.
Yeah, I think the book's gonna argue the opposite though. I think they're gonna argue that these people might be more pressured to go to class because they're playing on varsity.
Oh, they have to keep up the grades because the whole.
And they have to keep up their grade in order to play the sport. Yeah. So they might have scholarships and stuff like that. You often rely upon them being in class. Yeah. Yeah, I could see either way. The first 100-year students whom you meet at a student union. I think this is the one that, I think the book says that this one is the least biased or something, maybe.
Yeah, because those are like at random.
But these are people that are in a student union. Are they talking about like are they talking about like the place? I'm not sure. Because I know sometimes they got student union rooms. But this is also people that are sticking around campus. So it also like is probably going to be biased. I would argue that there might be a bias against people who work, because they're probably not going to stick around campus as long. So student workers, you might miss some of them. But how would that affect them going to class? Well, they're already at school, so they're probably the ones going to class. 100 first-year students taking honors classes. The key word there is what they're taking honors classes. So how's that going to affect them going to class? Again, there's probably on scholarship, honor scholarships. These are the people that are doing the best. These are the people that are going to be in class. They're the honor students. So you're going to have to write me some words on this one. I don't know what to say. Explain the bias, explain why it's a bias, explain how it might affect their attendance.
I keep accidentally hitting return. So that's why like my submitted answers it's like I've only answered 2 questions.
That's fine. Community push harder, yeah. Oh, does anybody have any questions on this one? Do you think this is something that's doable? Something that you can, because like I said, there's it's not going to be like clear cut. This is the number 32 math solution, right? You're going to have to explain to me and show that you understand sort of like what's happening here. So there's not a lot of ways I can plug this into a quizzes to make sure you're here and paying attention. So if you want to take the slack, I guess you can go ahead and take the slack. But, you know, as they say, don't go hanging yourself with it. That's usually what happens. So,
Oh, that was a good sentence.
oh, I'm sorry.
Dang it. But I basically said like the others were biased, and number 3 seemed less biased.
Oh, now we're doing types of studies. So I think this is like a multiple guess. We're back to the stuff that maybe you can BS your way through. I don't know. Identify the sampling method. Identify. Woo. I guess it copied twice or something. Or maybe this is the title of it. That's what it is. The title is called Identifying Sampling Method. So we want to identify the sampling method: simple random sampling, systematic sampling, convenient sampling, or stratified. So I talked a bit about this, but simple random sampling, just going through them right quick. This is like you choose a computer program, you number people 1 through 6, and you roll a dice. You have people pick a card out of a deck if you have less than 52 people, and you randomly draw one, right? Simple random sampling. Everything should be equally probable. That's what that word random means when we draw. Like when I roll a dice, each side has an equal chance of coming up. Systematic sampling is when we choose a really simple system. So every third, every fourth, every fifth, every 10th, something really simple like that. Ooh, excuse me. Convenient sampling is like I want to do the easy thing. Sometimes you have no options but convenient sampling. So I think the book gives like the anthropology example of collecting skeletons. Sometimes you can only collect the skeletons that you find. You can't go study the skeletons you haven't found or the ones that decomposed. So sometimes you don't have any other option besides convenience, but it is doing the easiest sort of thing. So if I want to sample high school seniors, the example for convenient sampling would be like the people in my class. Stratified sampling. This is when we start grouping things. So we put things into certain strata or groups, and we take things based on groups. So that is a pretty good quick rundown of what each of those means. So now we're looking at study the use of antidepressants. Selects 50 participants between the age of 20 and 29, 50 participants between the age of 30 and 39, and 50 participants between the age of 40 and 49. So which one is this an example of? Simple, random, systematic, convenience, or stratified? Herd nuggets. Yeah, this shouldn't take you too long to answer. Oh man, I would put these on like my quiz, my test, and I would give people the 4 different options to choose from, and I swear there will be like at least a few that just like they pick something out of left field. It's just like, why'd you even put that word on your paper? I gave you the words that you could possibly put. But All right, so I'm about to hit end on this one because it should not be taking y'all this long. It's one of those 4 options. I just detailed the option, just read it. What do y'all tell me? It should definitely be stratified sampling. Why is it stratified sampling? Where are my strata? What am I talking about? Here's one group of people. Here's another group of people. So I'm grouping these people into groups by their age. So if I'm grouping people by age, if I'm grouping people by gender, that is stratified sampling. If you tell me simple random sampling, I could maybe see why you might want to say that, because it might be contained within here. How do we select the 50 participants in this group or this strata? That could be random sampling. But the fact that there are strata is what makes it stratified. So the fact that we're grouping them by age is going to make it stratified. Questions about that? It really has to do with grouping. Anytime you group them, it's going to be stratified. And why would we group them? You want to see whether it makes a difference what age they are. So we want to see if the group is important. Let me clear this. Are there any questions on this one? I think we get something pretty similar in the next slide. Pick the sampling method. Take 2. Every 100th cast iron pipe that comes off an assembly line is tested for strength. I will give you maybe a hint. There is a keyword here. I'm really looking at that. That's your keyword there. It's not loading, is it? I don't know. I answered. Should be showing that. 10. All right, that's 10 people that answered. So if you do every 100th, oh look, we got a full deck. So if we're doing every 100th, that is a simple system. So if I'm doing a simple system, it is systematic. Oh, that is beautiful. Look at that. Look at that green tower. Okay. And I think this is the last one. I could be wrong. The last one was simple. Was with sampling methods. So we have the 4 sampling methods. I can't talk today at all. That bruise is like right on my lung too. When I breathe in like really heavy. I know I'm just being complaining, but okay. Student ID numbers are randomly selected by a computer for a survey of student opinions on college athletics.
There is a beautiful word that just gives it all away in that one
Pretty
question.
much, right? It's randomly and it's selected by maybe a computer. But that keyword random should just tell you that is a randomly selected sample. Simple random sample. And so they're distinguishing because, like I said, you could have random sampling within the stratified samples. But this is simple. Keyword, there's no strata, right? Simple is what they mean when they say no strata is what they mean when they say simple. Yeah, that's what I'm going to say. I almost said it backwards. But yeah, that's it. Now I think we got some things to talk about. A series of things. Type of study. Determine whether each of the following studies described as observational or experiment. So it's an observational study or an experiment. And then after that, if the study isn't, ooh, this is all like clashing together with my options down there. Okay. If the study is experiment, then we got to identify the control and treatment and whether single blind or double blind is necessary. If the study is observational, then we're going to state whether it's retrospective. And if it is retrospective, then it has cases and controls. So this, I know it says a lot right here, but they're basically defining what a retrospective study is. So a retrospective study is something that has cases and controls. It's a study that you do that lines itself up kind of like an experiment. So if we do a study, can I highlight this and it like not do that? There we go. Well, that just shows both of them. So study at the University of Southern California separated 108 volunteers into groups based on psychological tests designed to determine how often they lied and cheated. So I don't think this is out there. I think we already went over that section with the lie detector tests and determined that they weren't very reliable. But let's pretend like they can do this. It's an imaginary test. So somehow they're going to determine whether they lied and cheated. Those that have a tendency to lie had different brain structures than those who did not. So is this an observational study or is it an experiment? Are you observing people or are you setting up a control and variable and making people do things? So this is it's kind of like whether you're proactive in it, right? I think is what they're kind of asking. Are we proactively doing this and requiring people to commit an action or not commit an action? Or are we just like kind of looking back at what has happened? They kind of tell you right there with that first word. If you're doing a study, it is observational. They're just studying it. They're not telling people to go out and lie, right? They're only observing whether they have lied or not. So if they were like, I want you to go lie, that would be an experiment. They're like, I want you to lie. I want you not to lie. I want you to lie, right? That would be an experiment. You're getting people to do things. You have a control of people that are telling the truth. You have a variable of people that are lying. That's not what they're doing. They're looking at people. They're observing their behavior. So this is definitely an observational study. Now that we determined it's a study, is this study retrospective? Can I put it into case and control? So by coincidence, it might be that your observational study sets itself up like an experiment. And we have a case group and we have a control group. Or it may not have a case and control group. Is there a case and control group here is what they're asking. If there is, it's retrospective. If not, then it's not retrospective.
Sorry, can you repeat the difference between retrospective and not retrospective again?
So retrospective, it kind of naturally lines itself up kind of like an experiment. We have a case of people that are doing something and a control of people that are not doing something.
I'll be right back. I'm gonna quickly grab a snack.
Ooh, did you answer? Okay, you already answered.
Yeah, I answered. Don't worry.
And so on this one, they say that it is retrospective because we have cases and controls. And so let's talk a little bit about what our case and control would be then. I think it's the next question. It should be retrospective. And the next thing is to talk about the case and control. So if it's retrospective, you should be able to get me a case and control, and vice versa. You should be able to tell me case and control. So a bit of a trigger warning. They are going to talk about abuse in like the next one. In one of the next slides, it's one of the examples. But case and control. I think one of the next ones talks about sexual harassment. I think is what it talks about. So if I'm talking about this, I'm doing a study and using some kind of psychological test, I determine how often this person lies and cheats. And then I look at their lying and cheating and I determine that they have different brain structures. So what is my case and what is my control here? What's my variable? What's the thing I'm testing? Because this is like your variable. What is your case? Case would be the liars. Yep. And the control would be the, not liars, the truth tellers.
The truth tellers.
Make it sound significant or something. So that's basically it. And so based on whether they lie or they don't, we can determine their brain structure is the argument here. And so there's this variable of lying or not lying, and that variable can determine your brain structure. So I know I said they have variables and not variables, but you're making a link between the variable and the not variable with something else is also important. I think that comes up in one of the future examples. It's like they do have a difference, but they're not determining something. These are actually determining something. Okay, so being able to pick up the variable, being able to do what? A case is very much like your treatment group, the thing that gets the variable, and your control is very much like, oh, it's the same word, never mind. It's still a control group. Those two things are very synonymous, except one's for an experiment and one's for a study. Okay. Questions about this example? Some of them definitely make me think for a little bit, a few seconds. Oh, magnet example. Type of study. Determine whether each of the following studies describes observational. Same thing. In a study of the effects of magnets on back pain, some subjects were treated with magnets, while others were given non-magnetic devices with a similar appearance. Placebos. And that's from the magnets did not appear to be effective in treating back pain, was their conclusion. So is this an experiment or is it an observational study? I'm sorry, he'll be off there by the next slide if he scares you. If you get the reference, you get the reference. If not, I don't know. I guess you have to go look up the video for miracles if you don't get the reference. It became an internet meme for a minute. Okay, yeah, it is experimental. You are applying this, right? You are giving them a magnet. You're applying that treatment. You're telling them, go use this magnet or don't use this magnet. You're telling people to do something. If you're telling people to do something, I almost guarantee you it is an experiment. You are being proactive in it. You are getting them to be proactive in it. That would be an experiment. So now, if after it's an experiment, we need to know what the control group is. We need to know what the treatment group is. The control group, the treatment. So what's my control? What's my treatment? And then we'll talk about single or double blind.
Wait, control is the one with the magnets, right?
Control would be the people that got, the treatment.
Oh, that's treatment.
The treatment would be the magnets. So the treatment group would be the people that got magnets. And if the treatment is the people that got magnets, the control group would be the people that got what?
The fake.
They're basically placebos, right? They
Placebo,
give you
yeah,
something that
placebo
looks like
effect.
a magnet, but it's not a magnet.
The whole placebo effect, right? One gets a pill and the other gets one that's told it's the exact same thing.
Yeah, this is basically the equivalent of a sugar pill here, right? I'm going to give you a piece of metal that's not magnetic. All right, so do I need to do single blind or double blind, and what's your reasoning there? Should I do single blind? Should I tell the person that's being experimented on whether or not they're getting a magnet or placebo? Is that going to affect your outcome if you tell the person? If I tell you you're getting a placebo, is that going to
Then
affect how you see the outcome of the experiment?
I believe so, yes.
Definitely, right? You definitely need to do single blind. Because if I tell the person being experimented on they're getting a placebo, they're probably expecting it not to work. If I tell them they're getting a magnet, they're probably going to expect it to work, right? And so you get this thing called the placebo effect. And so you don't want the placebo effect, or you want to account for it. So you're going to give these people a placebo and not tell them they're getting a placebo. You're going to give these people a magnet and not tell them they're getting a magnet. So that would be single blind. The other part is double blind. Do I need double blind on the study? So the person giving them the magnet, should they know whether it's a magnet or placebo?
Yes, because that's how they know like which one works, which one doesn't, right?
Well, you could do some kind of coding and not tell the person giving them the magnet. There is a way to code things so that the person giving them a magnet doesn't know whether they're giving them a magnet or placebo. I would say it like this is kind of my opinion on things. Like usually double blind, it's probably better if you just want to like get around things, but it's probably not necessary on this one. And I think the book uses an example of like something with ADD or something like that, right? And so the person giving them the quiz is going to have to answer whether or not they were hyperactive or something like that. Well, if the person giving them the quiz knows whether they got a placebo or they got the ADHD treatment, right? That's going to affect how they see the person. So sometimes, and it depends how they do the experiment. There's a way to do this experiment to where you don't get that sort of factor in here. You can give the person on a scale of 1 to 10, how do you rate your back pain, right? Something like that. That's not going to come into effect where the experimenter's perception is going to bias the study. It might make it better. Maybe you're afraid of it. I don't know. Like I said, it depends how you phrase your questions, right? If these people over here, if your experimenter is determining whether or not they're in pain, then yeah, then you also want to double blind it. But your experimenter is probably not determining whether they're in pain. It's probably the person themselves. They're probably going to give you on a scale of 1 to 10 or something like that. And so that will kind of help make this not necessary, because those are more definitive. They're not sort of opinionated things. Is this person hyperactive? What does that mean? You know, what does it mean for a person to be hyperactive? Those are very opinionated sort of words. This is a person in pain, that's less opinionated. So I feel like there's less of this person's opinion coming through. So I would say it's probably not necessary, although in my opinion, it's probably always better to do a double blind than a single blind, just so you don't have the experimenter's bias coming into there, right? Because how are they asking them on a scale of 1 to 10? How good do you feel? Or on a scale of 1 to 10, how bad do you feel? Right? Just the slightest word in what they ask can change how a person answers something. So if you want to avoid that, then double blind would be the way to go. Although here it's probably not necessary. And if I were to guess, the book is probably going to say it's not necessary. Although this is an even problem, so it wasn't in the back of the book, so I don't really know what they said. Are there questions on like what single blind and double blind means? That's the main thing to take away.
I don't think there's any question. Oh wait, what?
So single blind means the person being experimented on doesn't know. Double blind means both the person being experimented on and the person conducting the experiment don't know.
Oh, okay.
Don't know whether it's the treatment or the placebo. So that one you definitely want to do single blind. Double blind is probably not necessary. So I think this is the same exact thing. Is this observational or experimental? A study at Brown University social scientists found that 18.6% of first-year women students surveyed at an upstate New York college experienced sexual assault during the first year. So this is kind of a horrible example, but I do think it brings home like kind of the point of what an observational study and an experiment are. And so I hope you really don't say that one. There's one way that this could be conducted ethically, right? Basically. So keywords there is it's a study. What are we doing? Oh, whew. I hope you told me observational. This is not experimental. You're not going to go tell people to go molest people, right? I hope not. You're going to observe whether or not it's happened. And so if this is observational, is this retrospective or not retrospective? So is it dividing itself up into cases and controls? This one is a little bit difficult and it's a little weird. Because we do get different groups, but what are those groups telling us? Are they determining another factor? So like when we had people that lied and didn't lie, it was determining their brain structure. Here we have people that like have been assaulted and we have people that have not been assaulted. So maybe you might think those are cases and controls, but is that determining anything? Is that determining another factor? Are we grouping that and saying that this is some kind of determining factor on something else? Where are we at? One more person. Okay. So it's not really determining anything. We have people that have been assaulted. We have people that have not been assaulted. But there's no sort of conclusion that they're drawing from those that have been and have not been. And so this is not going to be retrospective. Are there questions about that? Okay. So the idea of an experiment is you do like a treatment and you do a control and you try to see whether or not this has an influence on another sort of factor out there. And when we look at retrospective studies, it should line itself up coincidentally like an experiment. And so since there wasn't another factor that thing was determining, it wasn't really retrospective in that nature. Does taking a daily multivitamin reduce the incidence of stroke? 41-46. What type of study? Okay. Now we want to describe what type of study, what type of statistical study is most likely to lead to an answer to the following questions. So are you going to do this with a study or an experiment is what they're going to ask. And then if you're doing it with an experiment, single blind, double blind. If it's a study, state whether it's a retrospective study. those are weird directions. I think they're asking which way should we do this. So what type of study, if you were going to determine just taking a multivitamin reduce the incidence of strokes? Is that what they're asking? I thought that was what they're asking.
I have no clue.
Yeah, because it seems weird the way that they're asking it.
It's the wording that just makes it confusing.
Because they didn't actually conduct a study. They're asking, how would you do this? So are we going to do this with an observational, or are we going to do this with an experiment?
An experiment?
Yeah, you could do this with an experiment. It's fine to, you know, probably prescribe people daily multivitamins. We're definitely going to do it experimental. So we're going to do it experimental. We need our control and treatment. So what would our control group be? What would our treatment group be? So what are you going to do with the control group? What are you going to do with the treatment group? Experiment. All right, now we're going to answer that. Treatment group is people who do not take the multivitamin. So if they're not taking a multivitamin, are you just going to tell them you're not taking anything? What are you going to do?
You just give them the thing and tell them this will help.
Yeah, they're taking a placebo, right? You should give them a placebo or a sugar pill. And then this would be the people what? Taking the multivitamin. Vitamin. Okay, spelling is correct. We definitely want to do this experimental. Our control is going to be people taking a placebo. You're going to give them a sugar pill, say, hey, this is a vitamin, take it, see what happens. So if you're giving people a placebo and you're giving people a vitamin, is this thing going to be single blind?
Yes.
Yes. So this thing definitely should be single blind. Do I need to do this double blind?
Not necessary.
Yeah, it's not necessary. I don't think there's a whole lot of ways people are going to fake a stroke, right? Maybe they figured out one way. I don't know.
How?
Yeah, people aren't going to be
They just
dishonest
have like
about
a-
that. You're gonna figure out pretty quick if people have a stroke or not, right?
They just have like a shock collar and just like, okay, go.
Yeah, I don't think the experimenter is going to influence whether or not they said they had a stroke or whether or not we have the medical record that they have a stroke, whichever way you're finding out. But yeah, I don't think experimenter bias comes in here. The experimented, we definitely have to take into account the placebo effect, right? So we have to give one a placebo, we have to give one the other. We have to tell both of them, hey, you're taking the thing. So this is what they did. And it raises a lot of moral and ethical quandaries sometimes, right? And I've heard this with what we're going through now, right? When they did the vaccines and stuff, they had to do this control and treatment. Like, is it ethical? At what point do you give the people that were taking the placebo? At what point do you give them the actual treatment, the actual vaccine? Because the sooner they do that, the less information they sort of have on what it does in long term versus the placebo, right? They're getting valuable information the longer that they let these people go. But like, how long do you let these people go morally without a vaccine for something that's dangerous, essentially, right? So this definitely brings up a lot of moral quandaries sometimes that aren't really sort of clear. Are there questions about this? And like I said, like a lot of this stuff, I know it's a lot of stuff to put in there. I kind of have it in open-ended questions. And so I'm hoping that going through it in class, I know you may not answer all these with these open-ended questions. But like, if you don't understand something, like I hope now is like the time you speak up. And like I said, you can slack out and not do it if you want, but like you're gonna take a test over it. So I don't. You pull the slack, you're gonna end up hanging yourself with it. I guess is what I'm trying to say. Margin of error. The following summaries of statistical studies give a sample statistic and a margin of error. So find the confidence interval and answer any additional questions. A poll is conducted the day before an election for the state senator. There are 2 candidates running. The poll shows that 53% of the voters surveyed for the Republican candidate with a margin of error of 2.5 percentage points. Should the Republican be confident that she'll have a victory party? Why or why not? So what is my margin of error?
What is the confidence interval?
The confidence interval is what you're getting from using this 53% and this margin of error.
So it's like 50 or like 51.
It's 50.5
50.5.
to, was it 55.5?
It was 50.5 to what though? 'Cause we don't have, wait, what's the percentage of the
Should be 55.5. We're going each direction of that. So we do 53 minus 2.5, right? And we do 53 plus 2.5. And that should get us,
that's 55.5.
it should be 50.5% to 55.5%.
I guess I don't really understand like how to use those numbers. What do I?
So they don't tell us what they say confidence interval. This is the kind of the weird thing. Because usually when they talk about a confidence interval, they will give you another percentage. And let me just throw something up there. So usually we do like 95% confidence. That's just the general thing that we kind of default to. Not really a good reason, other than it just like gives you a number to work with. But we have like a 95% confidence interval. So what we would say is that we are 95% sure the candidate will receive between 50.5 and 55% of the vote. If we had a 98% confidence interval, it would be a smaller interval because you're talking about, well, no, it'd be a larger interval because you're talking about more people. If you had a smaller confidence, it would be a larger interval. So you get this trade-off between accuracy and how confident you are. So let's say this was like the 95% confidence. It'd be like something like 50.5 to 55.5. But if I wanted more confidence, I would have to sacrifice a little accuracy on my interval. So this is something that comes up. It's not something that they go really into depth in this book. They just kind of say plus or minus the margin of error. Just know that that's your confidence interval. But there are different levels of confidence that we can talk about. And this is sort of like, are we talking about, I don't know, 40 to 70 or something? I'm just kind of, let's do 43 to 73. That way it's even on each side. Plus or minus 30, is that right? 10, 20? Nope, did it wrong in my head. 33 to 23, that would be 20 points each side, right? Yeah, that's it. I don't know if this is real, but this is just sort of like an example. If we have more confidence, we're going to have a larger interval. If we have less confidence, we're going to have like a smaller interval. So if we're like 68% confidence, it could be like from like 52.5 to, what am I doing? 51 point, no, I'm doing 0.5, 53.5. That's it. I don't know how to do math anymore. So you get a sort of trade-off between how confident you are and how big your interval is. Is kind of the moral of the story that I'm trying to get at here. Although the book does not go too in depth to that. So if we're talking about a 95% confidence interval or 50.5 to 55.5, should they be confident that they will get a victory? So are they going to win? So if we know they're going to score between what, 50.5 and 55.5, are they going to win? Is this thing slow or y'all just slow? Which one is it?
I think your computer just needed to be refreshed.
Okay.
There it is.
So they should have a victory. They need to score over 50. Are they going to score over 50? Yeah, they're barely eking it out by half a point, right? But they're there. They are over 50%. They will definitely win. If we wanted to be 98% confident that they would win, we don't have that, right? If these were our numbers. I made this stuff up just to get at that sort of pattern we have. I don't actually know what their intervals are. But it's like one of those things when it happens, you can do a survey, you can get surveys, and your surveys might tell you it's going to score exactly 53%. But the odds of them getting exactly 53% are really low. It's usually going to be within some sort of range, right? Just like when we're making a piece of machinery, we're making we're making a nut that's got a certain diameter on it, right? That machine's almost never going to print out that exact diameter. It's going to have a little leeway on each side. So if we want to be very confident, 98% of our stuff would be between like 33 inches and 73 inches or something, right? If we wanted to be less confident, it's going to bounce around there. And a smaller interval. So they definitely don't go like that sort of deep into like confidence intervals. But I think they say maybe something about 95% confidence interval or something. Consider the following statistical study. A Fox News poll of 900 registered voters found that 19% of Americans regift. Women are more likely to regift than men, 21 versus 16%. And the results are nearly independent of income. The margin of error was 3 percentage points. Okay. So there's that saying, there's lies, damn lies, and statistics, right? Something like that. But there's also that saying that numbers don't lie, but sometimes people do misinterpret them. So you got to know what the numbers say, right? And what they don't say is also important. So what is this telling me? I got this poll of voters, and they find that 19% regift. They find that women are at 21 and men are at 3, and the margin of error is 3% points. So what is my interval for women? What is my interval for men?
Wait, are we supposed to answer the population
I
question?
thought we were answering the population question.
Oh, sorry. Yeah, identify. Sorry, yeah, that's what it says. Identify the population in the population parameter of interest. So what is my population? Who are they pulling? What are they trying to get? My population is going to be all Americans here. The population parameter of interest is going to be what? Something about regifting, how many people regift, percentage of, if we're talking about the population, we're talking about percentage of Americans that regift. So your population parameter talks about your population. I think we're going to go probably into sample next. What is the sample and the sample statistic? Is that what's next? I forgot they break these up into A, B, C, D. I think it's the last two we got on here. Okay, Fox News poll of this, what does it say? Describe the sample and sample statistics. So the sample and sample statistics would be what? This word right here.
The 900.
Yes, that's my sample. My sample statistic is what? Probably this 19% regift. And they have it stratified with men and women. So I know I probably said this in the notes, but like one of the really good things about statistics is that it's a really good sort of, it doesn't always tell you what the things are, but it tells you what things are not. It's a really good sort of like bullshit detector. Right? It lets you know when someone's claim that they're making is not true, or it can. Sample statistic would be, yes, the percentage of Americans that do or do not regift would be my sample statistic. And what does the next slide say? Identify the type of study. So what type of study is this? Is this experimental? Is it observational? Is it retrospective? So I think it's observational. I don't think this would be retrospective because they're not drawing anything based off of like whether they regift or not. Maybe they're trying to draw something, or maybe they're trying to hint at like some sort of gender bias here or something. So that might be what they're hinting at, but they're not coming out and saying it. So I'm not really sure. I would think it's probably not retrospective. It seems like they might be hinting at a conclusion, but not necessarily saying it. Given source. Margin of error. So what additional facts do you need? What additional facts? Discuss what additional facts you would like to know before you believe the study or acted on the results of the study. So the key thing here that is like seems kind of obvious to me, right? If we're going to talk about women's margin of error or men's margin of error, and it's not really clear. I think this 3 points applies to each of these individually. So what would their margin of error be?
Is it the 21 and the 16%? Oh wait, no, it's a 3 point. It's a 3%.
Yeah, so we're taking 21%, and there's a margin of error of 3 percentage points. So how low could this possibly go?
18.
Yeah, so a woman could be anywhere from 18 to what, 24%? 21
Yeah.
plus 3. And men could be anywhere from, I think, 13% to 19%. And so if this is your accuracy on your test, can you conclude that women regift more than men?
Yes.
Can you?
Look.
Is it possible that women could be at 18% in reality and that men could be at what, 19% in reality?
Well, we don't
yeah,
know
that's good.
how many women and how many men they tested on. So they could have tested on more women.
Oh, that's a good point.
Yeah,
We don't know the specifics.
Yeah, we don't know sample size. We don't know how many come in each strata, right? We don't know how many women they tested. We don't know how many men they tested. But also, we don't know that men is going to be less than women. It could actually be more given their margin of error, because the highest men could be as 19, the lowest women could be as 18. If that's the case, which it could be given their margin of error, women could actually be lower than men. So this is not their conclusion if they're trying to draw something about women and men, women being more likely. Their conclusion is not really supported by their evidence or their study, right? And it's not if we can, because we consider the margin of error, right? If you consider the margin of error, the study is not an accurate one. We can't really draw conclusions. Yeah, that's it. Any questions on this one? I think the main thing is that like there's some overlap when we start talking about the margin of error, right? And if there's overlap, one of them could be more than the other. It didn't tell you which one is more than the other. Okay. I think we got one more question after this.
Yeah, it's one more, but it's broken down into the 4 parts.
Yeah, it's the same question, but a different question. It's the same thing, but
different. Wait, how different questions, same questions? Wait.
Yeah, it's the same thing. Consider the following statistical studies. We're going to do A, B, C, D again on this one. So this time our study is the phenomenon of stereotype threat occurs when people, often women or minorities, are reminded before taking a test that the test will be used to evaluate intellectual or academic abilities. Studies show that test performance declines significantly when such reminders are given compared to when they are not given. So whether you remind someone that they are being tested or not, especially if they're from a population who has faced discrimination, right? They're going to be much more likely to not score as well. This reminds me of the blue eyes, brown eyes experiment, if you know her. Was it Jane? Is it Jane Elliott? Is that her name? Yeah, Jane Elliott. That's it. If you know Jane Elliott, she lived in like, it was a pretty stagnant town, like racially. And she like conducted like this experiment, blue eyes, brown eyes. If you just like Google her name, you probably find videos of it. It's pretty interesting. And it's pretty, what do I say? It's one of those ones that gets cited quite often.
So would the population just be people?
But yeah, but she shows this phenomenon in there too, a little bit. Just based on their eye color, she basically kind of discriminates against them. This is the whole thing. But identify the population and population parameter. So what are we talking about? I would say we're probably talking about probably the world population, unless they're trying to narrow it down to like a specific country. That would probably be more accurate when it gets down to like stereotypes and things of that nature. Those tend to be more localized than worldwide, but some of them are worldwide too. I don't know. So I would say either the world population or the U.S. population. They're probably talking about all the population. The sample here. Oh, population parameter. Sorry. So we're talking about all the population, and then the population parameter would be the test performance of all those people.
So it's like world population or something, right?
Yeah, I would say either the world population or the U.S. population, and then the population parameter is going to be how they scored on the test. We want to record how they scored on the test. That's the thing that we're measuring. The thing that we're varying is whether or not we talk about they're being tested. And so we're not going to go test every minority and every woman out there under the face of the earth. we're going to pick from those people. And did they pick from those people? They talk about, you're talking about probably this study, right? The study probably picked people from them. So the sample would be the people that you picked. It's not every single woman and minority out there. The sample statistic would be, how did the people that you pick, how did they score on the test? What is the test score of the people that you picked? So I don't even think it says, no, didn't say. Yeah, that's it. And then the second to last. Oh, come on. Second to last thing we're going to talk about is, what do they say on this one? What more do you need to know? Identify the type of study. Is this observational or experimental? So it depends how they're doing this, but are they reminded before a test? So are you actively reminding these people, or are they just being reminded? Are you looking back at a study to see whether they were reminded? I think this, the way that they're talking and wording this, it definitely sounds like they are either telling this person or not telling this person before they give them that test. And so if they are proactively either telling this person or not telling the person, it should definitely be experimental. So before they take the test, they're telling them words. I'm either going to tell them these words or I'm not going to tell them these words. If I do tell them the words, does it change differently from if I don't tell them the words? That would be an experiment. And I think we're almost done. Is this the one that says, what more do you need to know? What additional facts would you need to know before you believe the study or acted on the results of the study? Did they actively tell them? You might want to know how they pick these people. How are you getting your sample? Is there sample bias in there? Excuse me. What's the margin of error? These are all things that we would want to know. Even the thing with race and everything, it's unique to a country, right? What race you are in this country may not be what race you are in a different country. So when you start talking about things race-based, you probably want to know how other countries are scoring. Why is it like cancel out of that? It's weird. You probably want to know how other countries are scoring as compared to yours. Is it something that exists within America that is unique? Because we also have a unique melting pot sort of approach to how we do things in America, and racism has taken sort of different forms based on that, you know. I'm thinking about this. Yeah, so discuss results of the study. So margin of error, that sounds like a good thing to know. So there are probably lots of things you could tell me that would be correct here, right? Oh, that's it. Never mind, that's it.
Yeah, that's the last one.
All right, so are there any questions?
That's the first time I've ever been first.
Yeah.
I got in the top 3. I'm happy.
I was reminded by I listened to an NPR article and I was aware of like some of the facts, but like they were talking about race in America and it was pretty interesting, and they were talking about like how a lot of it was like a lot of racism pre-America was like more sort of tribalism, because you had different sort of sections. People were really sort of divided pre-America. And then America comes along, we have the melting pot idea, and it becomes a lot more of sort of like this internalized sort of thing where you have to subjugate people within your own country. And those people, the Jim Crow era eugenicists, they mentioned about how like they were basically like one of the major influences of like, you know, Nazi Germany and those sorts of things. So that's where my brain was going. Definitely a bit of a tangent, but it's something that's been on my mind a little bit in these last couple of years, if I'm being honest. It's kind of disturbing. Okay, any questions? Sorry to throw out something like that at the last minute, but here we are. If there's any questions, I'm here for it. If not, that's what I have for